electrons are atoms with a charge due to the loss or gain of electrons. In my previous video, we saw how to draw the electron configurations of atoms. And so if I quickly draw an atom of sodium and its electron configuration, we can see that sodium has 11 electrons, and there is 1 electron in its outer shell or valence shell. Now, sodium, just like all of the other atoms in the periodic table, they want to have a full outer shell. So the easiest way for sodium to have a full outer shell is to lose the single or 1 valence electron. So all atoms, they want to have a full outer shell. And this is because with a full outer shell, they are more stable. More stable. So if sodium loses its outer shell, it will look something like this. It will only have 2 shells, and its second shell, which is now its outer shell, will be full. Now the electron that it's lost, that will go somewhere. That's not created or destroyed. Law of conservation of mass. It will go somewhere, but it's lost from this atom. So now, to complete our diagram, we draw square brackets around the atom, and we give it a charge. Now previously, sodium had 11 electrons. Now electrons are negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It had 11 negative particles. And for each of these negative particles, it had a positive particle to cancel it out. So sodium has 11 positive protons. 4, 5, 6, 7, 8, 9, 10, 11. And each one of these cancelled each other out because they had opposite charges. But now, since sodium has lost an electron, it now has 1 more positive proton than it does negative electrons. So there is no electron here to cancel out that charge, which means that overall sodium is now positive. So we draw a positive symbol at the top. And so this would be the diagram for a sodium ion, and it would be drawn, it would be written something like this. If you had to write its electron configuration, it would be Na+, and then the electrons in the first shell would be 2, and then 8 in the next shell. If we look at another example, something like fluorine. Fluorine has an atomic number of 9 and a mass number of 19, which means that fluorine has 2 electrons in its first shell, and it has 7 electrons in its outer shell. Now fluorine wants to gain an electron to fill its outer shell. Now that electron does come from somewhere, it's not created, law of conservation of mass. But when fluorine gains this electron, it will form a fluoride ion. So if I draw the same thing, but now the outer shell is full, and I'm going to use a dot to show that that electron is foreign and it's come from somewhere else. So I can draw square brackets around it because it's now an ion. And what would the charge be? Well, it's gained a negative electron and it's gained 1, so overall it would have a charge of negative. What about if it loses or gains more than 1 electron? So magnesium has 2 electrons in its outer shell. If it loses both of those, it would form an ion that looked something like this. Now magnesium has lost 2 electrons, and so it's lost 2 positive particles, which means it now has 2 negative particles that don't have a positive charge to cancel them out. So magnesium would have a charge of 2 plus. Alright, I want you to try and draw the electron configurations of the ions for oxygen, for chlorine, and for lithium. So pause the video here and draw the electron configurations of these ions. Okay, and this is what you should have. Oxygen gains 2 electrons to fill its valence shell, so it has a charge of 2 minus. Chlorine, which becomes a chloride ion, gains 1 electron to fill its outer shell, so it has a charge of minus. And lithium, which has 1 electron in its outer shell, loses 1 to have a single shell with 2 electrons, which means it's full, and a charge of positive.